spring light falls into winter night.
Welcome to Fabulous Factoring Part 4. Before we get started on our notes, I'd like to look at this trinomial. And up until this point, we have not had a leading coefficient other than 1. The leading coefficient is the first coefficient in our polynomial. So the leading coefficient here is 3. And this can cause a problem. When we think about a polynomial, specifically a trinomial, and remember we said, is it of the form ax squared plus bx plus c? This is of the form ax squared plus bx plus c, and a would be identified as the coefficient of the first term, or 3. B would be identified as the coefficient of the second term, or 17, and c would be our constant. These letters are extremely significant and will be throughout the year. And when we have a leading coefficient other than 1, it can be a little tricky to try and factor it. So one of the things we do is we look at what we call the discriminant. The discriminant happens to be part of the quadratic formula, which you will learn later this year, and it tells us if a polynomial can be factored. So what is the discriminant? It is b squared minus 4ac, and that should go in your little box. And what it does is it tells us if a polynomial can be factored by whether or not it is a perfect square. If b squared minus 4ac is a perfect square, then we know we can factor it. If it's not a perfect square, then we're not going to waste our time. It can be kind of troublesome sometimes to factor things that do not have a leading coefficient of 1. So let's take a look at the two trinomials given to you. In the first case, we're going to work out what b squared minus 4ac is. Now keep in mind, what is a here? A is going to be 1. B is going to be 3, and C is going to be negative 4. So you have to plug that in your formula, b squared minus 4ac. You should do that on your own for both trinomials and come back and check the answer. So the discriminant in the first case is 25, and in the second case is 33. Why is that significant? Because I know in the first case that I can factor that trinomial. In the second case, I know that can't be factored. We have other ways of solving that if it were an equation, and we'll do that later this year. But for our factoring unit, we can't factor that trinomial. So I'm not going to sit there and try to do it over and over again when I know that it can't be done. This is a quick way to tell whether or not you're wasting your time. It doesn't take that long to do it, and it will tell you what you need to know. Okay, so the methods to use, we have, if the discriminant is a perfect square, then we know that it can be factored. So we have 3 different methods that we can use. We have guess and check, which many of you will be fond of and some of you will despise. So we have 2 other methods you can fall back on. We have the X method, and we have the multiply and maneuver, or people call it slip and slide. Okay? In order to do that, let's first take a look at guess and check. Guess and check is going to come after we actually do the discriminant. So go ahead and figure out the discriminant there and make sure that we can factor that. The discriminant should be 225, which is a perfect square, so I'm good to go. Guess and check is pretty easy to use when this is prime and this is prime. Not too bad, because I know I have a 2x and an x. And then it can either be a 7 here or a 7 here, and the other factor is going to have to be 1. So I just can play around with it and see which one works. Let's say I put the 7 here and the 1 here. Now again, this is a negative, so 1 has to be positive and 1 has to be negative. So that there are actually 4 possibilities of how I could do this. I could do plus 7 or minus 7, or plus 7 or minus 7 in the second term. You can see it gets exponentially more difficult when the leading coefficient and the constant are not prime. So we try it out. If I put a positive 7 here and a negative 1 there, I'm going to get a 2x and a 7x, the 2x being negative. That's going to give me a 5x there. That's not going to be good. So it's not going to be any different if I change it to the negative there in the first term and the positive in the second term. So what I actually have to do then is I have to go back and I have to change the position of the 7 and the 1. And then I have to figure out which one I want to be positive. Well, this is a negative 13, so I know I want the 2 times the 7 to be negative, so I'm going to put my negative there and my positive there. That is how guess and check works. Now before we do the X method, I want to show you the X method with some simple equations. For this part of the lesson, you can really just watch. You don't necessarily have to take notes, and this should give you an idea of what this method looks like. The first step in using this method is to take A and multiply that by C. So 6 times 49, that's not really a pretty product, but it works out to be 294. I'm going to put my product here and my sum here. We know the sum has to be 7. I want to look at factors of 294 that are going to add up to 7, or in this case subtract to 7 because of this negative sign. I already know that 49 and 6 are factors, so we have to work backwards from that, and we can think of other factors that might work. Well, the prime factorization of 49 is 7 times 7, and that's 2 times 3. So I can kind of mix and match those a little bit and find something where the difference is going to be 7. I look at this and I see 14 and 21, and I know their difference is 7. So far, this process is not that much different than guess and check. Where it gets different is when we go back to rewrite the equation. And this is also known as factor by grouping. Factor by grouping, we are going to break out this middle term into a 14x and a 21x so that we can group the items together. I'm going to rewrite this equation as 6b squared plus 21b minus 14b minus 49. Basically, I have uncombined my like terms, and in doing so now I can factor by grouping, and I'm going to group these into a first binomial and a second binomial. So the GCF of the first binomial is 3b, and when I factor that out, I'm left with 2b plus 7. My second binomial here, I'm going to factor out a negative 7, which gives me 2b, look at that, plus 7. Be careful with this plus here because of the fact that this is a minus 7 out there and this is a minus. This would have to be a plus. This is really nice because I have these twin binomials that then I'm going to pull out, and when I pull those out, I'm left with 3b minus 7. Ta-da! Factored. So I'm going to go back to this problem, and I'm going to use the same strategy to solve a problem that we already solved using a different method. So again, the product is going to be 14, and the sum is going to be negative 13, and this is a negative 14 actually. So I want factors of negative 14 that are going to subtract and give me negative 13. So I know that's going to be negative 14 and 1. I'm going to rewrite this as 2x squared minus 14x plus 1x minus 7. And when I factor out the 2x, I'm left with x minus 7. And this is also coincidentally just x minus 7 times a 1, right? So I can factor out my x minus 7 out of both terms. Those are my twin factors. And what's left is 2x plus 1. Ta-da! The last method that I'm going to show you looks very complex, but in essence it's really not that bad. So stay with me and we'll see what we can do. The first thing you want to do is multiply a times c and rewrite the equation without c. So a times c is going to give you negative 14, and now all of a sudden a has disappeared. Don't worry about that because here we multiplied a and here we're going to divide by a. Okay, so we are doing things that are mathematically correct. Now I want to factor it, and it's going to be easy to factor, and then I have to divide everything through by a. Well, a was 2, so I'm dividing those constants by 2, and I get 7 here and 1/2 in the second binomial. Now I don't want to leave a 1/2 as one of my factors, so to make this a little less complex, I'm going to multiply just this through basically by 2. And what that does is it moves the denominator to the front of the binomial. So I get x minus 7 times 2x plus 1. So let's take a look at this one, and we'll do it 3 different ways. If you feel confident and you want to just try these on your own, go right ahead and come back and check. So the discriminant here, a is 2, b is 23, and c is 11. When you figure out the discriminant, and you should do that on your own, 23 squared is 529 minus 4 times 2 times 11, I get a discriminant of 441. That is a perfect square, so I'm good to go. So now I need to factor this. Trial and error. Trial and error, I got a prime and I got a prime. So this is a haha prime example for guess and check. I know one of my factors is 2x, I know the other one's x, the only thing I need to do is figure out where the 11 and the 1 go. And the 11 and the 1 are going to go here, and they're both positive. So this is really a textbook case, trial and error, easy to do, should be no worries. But let's try the other two just so you can get more comfortable with those. In the first case, 11 times 2, 22. I need a product of 22, and I need a sum of 23. Again, pretty straightforward, but let's say it wasn't, so I need 22 and 1, I need 11 and 2. We know that these have to be the case, so I'm going to rewrite this factor by grouping, and I'm going to go 2x plus 22x plus x plus 11. And then I'm going to go ahead, that's 2x squared, and I'm going to take out my 2x, I'm left with x plus 11, and then I get plus, and this is just again a 1 times x plus 11. Take out my twins, and I'm left with x plus 11 times 2x plus 1. Now the next strategy is the one we really need to focus on. Again, trust me on this, it is nice sometimes, okay? So I'm going to multiply a times c and rewrite it without a. That becomes x squared plus 23x plus 22. That's easy to factor, x plus 22 and x plus 1, but ooh, gotta undo what I did and divide both of those constants by 2. So I'm going to get an x plus 11 and an x plus 1/2, and then I'm just going to go ahead and take care of that 1/2 by multiplying my front term in the second binomial by 2. Why don't you go ahead and see what you can do with 3 and 4. 5 is just a review, mixing it up from what we've had in the past. And we are going to work extensively on the factor by grouping, which is the X method, and the multiply and maneuver method tomorrow. So have a great night, and I look forward to seeing you.